In this lesson, you'll learn about two specific types of right triangles that are special right triangles. And the objective of the lesson is to use the properties of a 45-45-90 right triangle and a 30-60-90 right triangle. The first statement says that it should say that if the acute angles of a right triangle are both 45 degrees, then another name for it is going to be an isosceles right triangle. So the isosceles right triangle is a 45-45-90 right triangle, because if you look at it, let's look at a picture of it real quick. If we have a 45-45-90 right triangle, if these two angles are congruent, then the isosceles triangle converse says that those two legs have to be congruent. So it is an isosceles right triangle. So the next theorem is about the 45-45-90 triangle theorem. And it states that in a 45-45-90 triangle, both legs are congruent, and the length of the hypotenuse is going to be the square root of 2 times the length of a leg. So that's just a formula that you need to memorize. Hypotenuse is equal to the square root of 2 times a leg. Or you could say that h is equal to leg times the square root of 2. So let's look at how that formula, where does that formula come from, and that'll help you remember it. It comes from the Pythagorean theorem. So let me scroll up. So in this 45-45-90 right triangle, if we look at the Pythagorean theorem, c squared is equal to a squared plus b squared. Of course, c is always the side opposite the right angle. And if we apply the Pythagorean theorem to this triangle, we're going to have c squared is equal to, both of the sides here, a and b, are both s. So it's s squared plus s squared. So just put in the s's in for the a and the b. So c squared is equal to, if you add s squared plus s squared, you're going to get 2s squared. And if you take the square root of both sides to solve for c, the square root of 2s squared. I can take the square root of the s squared, but I can't take the square root of a 2. So the 2 has to stay under the radical, and I can take the square root of the s squared out as s times the square root of 2, which is what we have in the diagram. That's where that s times the square root of 2 comes from. So hopefully that'll help you remember the formula to know that it actually comes from the Pythagorean theorem. So let's look at the next theorem for a 30-60-90 triangle. In a 30-60-90 triangle, the length of the hypotenuse is going to be twice the length of the shorter leg. And the length of the longer leg is going to be the square root of 3 times the length of the shorter leg. So the key to finding the lengths in this triangle is knowing the shorter leg, because the hypotenuse is twice the shorter leg, and the longer leg is the square root of 3 times the shorter leg. Well, what does it mean by shorter leg and longer leg? The shorter leg is always the leg that's opposite the 30-degree angle, because 30 degrees is smaller than 60 degrees. So the shorter leg is going to be opposite the smaller angle. The longer leg is always going to be opposite the 60-degree angle, because the 60 is the larger of the 30 and the 60-degree angles. So once again, the formula we have, this the hypotenuse is equal to 2 times the short leg, and the long leg is equal to the square root of 3 times the short leg. So once again, just remember that the short leg is opposite the 30-degree angle, and the long leg is opposite the 60-degree angle. We can look once again at how this formula is derived to help you remember it. If you look at an equilateral triangle, if you look at an equilateral triangle, you have a 60, 60, 60. We have, draw the altitude. So that means that we have a 30 and a 30 at the top. So we have two 30, 60, 90 triangles. And the altitude of this triangle, we'll call it B. And the side, well, that's an S for the side, the short side of that 30, 60, 90. There's two 30, 60, 90 triangles here, so we have two short sides because we have two 30, 60, 90 triangles. So if the bottom side of this equilateral triangle is 2S, then that means that those other two sides of this equilateral triangle is 2S as well, because it's equilateral. So if you look at the Pythagorean theorem, once again, we have c squared is equal to a squared plus b squared. And look at one of the right triangles. Look at one of the 30, 60, 90 triangles. And the hypotenuse is going to be 2s. So we have 2s squared, in parentheses squared. The a, we'll let the a be one of the sides. So we got s squared is a, and then the altitude in the middle is the b. So if you square 2s squared, 2 squared is 4, and of course s squared is s squared. So you got s is 4s squared is equal to s squared plus b squared. So if you subtract s squared from both sides to get it off of the right side, you're going to have 3s squared is equal to b squared. And if you solve for b squared, which is our long leg, take the square root of both sides. B is equal to square root of 3s squared. I can take the square root of the s squared out as an s, leave the 3 under the radical sign, and that's how you derive the length of the long side of that 30, 60, 90. So the long side, which is b, is equal to s times the square root of 3. Your side, the short side, times the square root of 3. So let's look at some problems and apply these formulas. In problem 1, we're using a 45, 45, 90 triangle, which the formula says that the hypotenuse is equal to a leg times the square root of 2. Doesn't matter which leg you use because it's an isosceles right triangle. They're both the same length. So here, the hypotenuse is h and the leg is 8 times the square root of 2. And that's how you can leave the answer as 8 times the square root of 2. In the next problem, B, you have another 45, 45, 90. Same formula applies. Hypotenuse is leg times the square root of 2. The hypotenuse in this case is 5 times the square root of 2. And the leg is what you're trying to find. That's the x times the square root of 2. So you would divide both sides by the square root of 2. Square root of 2's cancel, and x is equal to 5. And you will, once you get used to using this formula and applying this formula to 45, 45, 90 triangles, you will be able to see that without having to calculate that. If the hypotenuse is 5 times the square root of 2, you will just immediately know that the leg has to be 5 because of the formula. Scroll down to problem 2. In problem 2, we have another 45, 45, 90 triangle, and it asks for the value of x. So write down your formula. Hypotenuse is equal to leg times the square root of 2 for a 45, 45, 90 triangle. The hypotenuse in this case, the side opposite the right angle, is the 10. The leg is x that you're looking for, square root of 2. So here we're going to divide both sides by the square root of 2 to solve for x. So x is equal to 10 over the square root of 2. But we cannot leave the answer with a radical in the denominator. We have to rationalize that denominator and get the radical out. So in order to do that, you have to multiply the numerator and the denominator by the radical to rationalize that denominator. So you're going to end up with 10 times the square root of 2 over, and the square root of 2 times the square root of 2 is 2. And then 2 will go into 10 5 times, and you can't put the 2 into the radical, so the square root of 2 has to stay there. So the simplified answer is going to be 5 times the square root of 2. In this problem, we're finding a specific distance in a courtyard. A courtyard is shaped like a square with 250-foot long sides. What is the distance from one corner of the courtyard to the opposite corner, round it to the nearest tenth? So if you draw a diagram of this, you have a square. So a square has right angles and it has congruent sides, just by definition of a square. So each side of the square is 250, and it wants to know the length, the distance from one corner of the courtyard to the opposite corner. So if you just draw the diagonal of that square, that is what it's asking you for. So this is the hypotenuse of this right triangle. And we have a 45, 45, 90 because it's an isosceles right triangle. So apply the formula. Hypotenuse is equal to the leg times the square root of 2. The hypotenuse is what we're looking for. And the leg is 250. 250 times the square root of 2. And if we, it wants it to the nearest tenth, so put that into your calculator. 200 times the square root of 2. The height is going to be to the nearest tenth, 353.6 feet. Next problem is finding the length of a side of a 30, 60, 90 triangle. We just need to apply the other formula that we know for the 30, 60, 90 triangles. We have two different formulas for that one. We need to know which side we're looking for. So in this particular one, x is opposite the 30-degree angle. So it's the short leg. So we're looking for the short leg. We know the longer leg The longer leg is 15 because it's opposite the 60-degree angle. So use the long leg formula. The long leg is equal to the short leg times the square root of 3. The long leg in this diagram is 15 because it's opposite the 60-degree angle. The short leg is the side we're looking for, the x, times the square root of 3. We need to divide both sides by the square root of 3 to solve for x. But we have a radical in the denominator, and we can't leave a radical in the denominator. So let's rationalize the denominator by multiplying the denominator and the numerator by that radical, square root of 3. So we're going to have 15 times the square root of 3 over 3 is equal to x. And 3 will go into 15 5 times. So that equals 5 times the square root of 3 is your final answer. In the last problem, we have the height. What is the height of an equilateral triangle with sides that are 12 centimeters long and round it to the nearest tenth? Let me scroll up on this one. Give you a little more room to draw the diagram. So let's draw the diagram on this one. We have an equilateral triangle. And the sides are 12 centimeters long. So if I draw the altitude of this equilateral triangle, I'm going to form a 30, 60, 90 triangle. And I've also bisected the base because that altitude is a perpendicular bisector of the base. So they have 6 and 6 for the lengths of that short side of that 30, 60, 90 triangle. And we want to know the height. So we want to know the long side, the long leg of that 30, 60, 90, the side that's opposite that 60-degree angle. So we're going to use the long leg formula. The long leg is equal to the short leg times the square root of 3. The long leg is what we're trying to find. The short leg of that 30, 60, 90 triangle is 6. So the length of that height is 6 times the square root of 3. It wants it rounded to the nearest tenth, so put it in your calculator, and that will be 10.4 centimeters.